We're on this roof today just to do a invasive inspection. We should only be here for about 4 or 5 hours just to cut up the roof to try and find out why this area is spongy. We've already taken the tiles up around the edge so that we can get to this area, but it was when you walked on it, this was very soft, and you can see why it's soft. Obviously this piece of wood's rotten. So we start to pull it up and we realise that underneath this particular part is this ply. The ply is only ½ inch thick, and underneath it is a sheet of green plastic. Green plastic indicates that it's supposed to be a vapor barrier. So you have to question, why would there be a vapor barrier at this level on the roof? Because a vapor barrier normally goes under the insulation, not on the top. Now when we cut the next piece out, which is this piece here, this green that we're taking up now probably is a gas open membrane. A lot of people call it breathable, but it's not breathable. It allows vapor to come through. Now if you've got that particular membrane there with a piece of plastic over the top, that doesn't work either, so we can't work out what's going on and why that would be. Now when I tap this with the screwdriver, you can see the top surface is starting to come away, so we know that there's some rot. And as we move further into it, we can see that it's rotten really deep down inside, but it's really interesting build up. We can't work out why there's so much timber here. We tap this piece and a couple of other pieces, really solid. It's not the kind of normal build up that we would expect to have here. So we need to go away and talk to the engineers and the people about the house to try and find out what's going on. As we go away, we need to make good for the night. So this is the hole made good for the night, so that if it rains, no water gets in. Now, before I go on any further, I need to explain the building to you. We're up on a balcony, access in through the doors here. All the way around the outside, we've got some parapet walls so you don't fall over. Now, you can see we've got scaffolding up here because we've gone away, we've talked to the owners of the property, we've talked to the engineers, and everybody's agreed that the whole thing needs to come up so that we can understand the building and how it's built, etc. We can't find any plans or anything for it. This is a different view from higher level. Again, you can see the area that we're talking about. This is the stairwell with the door that comes through into it. So what we're going to do now is we're going to strip the whole lot up and try and investigate into how that actually rotted, whether it was a leak into the roof from above that's rotted the timber, or whether it's sweating coming up from underneath. So I show you here, we've started ripping things up, and there's different membranes at high level, and we're trying to work out what's going on. It's really confusing. Now here we've taken the whole lot up, and you can see that the timber decking underneath it is completely rotten. Now we're starting to see certain things going on here. First of all, because we've taken all the cladding off the walls, we can see that water's been running down from the top. You can definitely see that there. You can see this is high level. These areas here, and here, and on this back area here, they can't be from a leak from the roof. This must be water running down. So if there was water running down to this area, was it a leak from the roof, or was it water coming down from this area getting in? And at the same time, we don't know whether or not it was condensation coming up from down below. We haven't discovered any of that yet, but as you can see, there's quite a lot of decay on this roof, and we're just trying to work out exactly what's going on with it. The outlet was very restricted. Even though there's a big hole here, the cladding came over and the outlet was just tiny in the center, so we've got to deal with that. Now this is the really interesting thing, is that we took everything up and we found that the timber work that we were chopping away on the top was extremely deep, solid timber work. Never seen anything like it before, and we had to go back to the engineers and go, right, now we've stripped this up, what is it we're dealing with? So after consulting with them, it turns out this is what they call a cross-laminated timber construction. And the actual area of wood which we've got, which covers the whole area, is supportive of the whole roof. It's structural. And of course, the top is rotten. So the question had to be asked, is that going to compromise the roof? Well, so far, the rot we found wasn't that deep. It's really interesting. This hole we found, we didn't make this hole. Someone else had cut this hole previously and looked down to the insulation below and checked the insulation inside. So even though the building isn't that old, there have obviously been problems with it somewhere along the line, because someone had taken the time to cut this great hole into it right in the middle of the roof. So this is a really good view of what's going on. Been trying to let this dry out, and because we've got a tin roof over the top, you'd think that no rain would get in, but actually we've got driving rain coming around the edges because the top of the parapet walls is taking the water and bringing it in, and it's dropping down inside. So when there's rain around, we're putting a tarpaulin over the top. When there's no rain, we're letting the air get to the wood to dry it all out, because it's really high in moisture, and obviously we don't want to be locking that back in. Now here we've scraped away everything on this, so we know that we're down to really good wood underneath this. All the rot is gone, and you'll see that this looks wet, and that's because we've just sprayed it with what we call a 5-star wood preservative. That will treat it for any beetles or any dry rot or wet rot, and will stop it from rotting any further, because it's been decided now that the water penetration was coming down the sides. If you look at this picture here, you can see that the water has been tracking down from the top of these coping stones, which is metal, behind of what's been going on. So we've taken all of the cladding off the walls. Now, what we don't know is whether or not the whole problem with the roof was to do with the water coming down from above, or whether there was roof leaks. But as there's no roof now and we're replacing the roof, well, we'll make sure it doesn't leak, and we're also going to make sure the water doesn't track down from up above. But one of the things that we're going to have to do is that we're going to have to oh, by the way, that's the hole that I was talking about earlier on that somebody else did, an inspection hole right in the middle. So it's pretty obvious that there was the problems with this roof right from the start. So one of the things we're going to have to do when we replace the roof is to vent it. It wasn't vented before. We know the insulation is under the wood. We know wood is natural and holds a lot of moisture. So what we've decided to do is to do a matrix of timbers over the top, and just underneath this, obviously you can see the old roof covering. That's all being treated, as I say, with this 5-star treatment for rot all up the walls. Everything's been treated all the way around. By the way, in the background there, we found an open soil pipe, which we've now capped and vented to the outside, so that's been dealt with. But that was just allowing gases to get into the structure, which was obviously not a good idea. Now, what we've done is change the falls on the roof, because the outlet is over here on the left hand side. We've put these furrings at the bottom, so we're making all the water run to this side of the roof, and then you can see it's fatter this end running down this end, so we've got other furrings going this way. Now this is also going to help with ventilation, because we're going to put ventilation all the way around the outside edge, so that the air can come down and get underneath this. Now any air coming down and getting underneath it can cross left and right, up and down. It's a great matrix of timber work here, to make all the falls go to the outlet, which is down here, but also so that the ventilation can get underneath there. And what I'm demonstrating here is the fall to the roof. Again, the outlet being this end here, so that's why all the water's being pushed down this way and that way, so that it can get out of the outlet. Here we can see the rubber's gone down. We've got the first parts of the vents going on. Now note the height of all this. We're having to make this side higher than everywhere else, because this is the side where all the water's running down, and we'll be putting decking on, which will be level to walk on. The decking will be raised off of the top of the roof elevation down here, so everything at the moment looks like it's really high because of the decking going over the top. But when we're finished, we still want this vent to be high enough so that the water doesn't hit the decking, bounce and go back up inside. Once we've clad the walls all the way around, we'll make sure that the top here is vented as well, so any air that gets in and around and goes into that vent down there will be able to flow underneath this roof everywhere, but also it will be able to get in there and flow up and then come out just underneath this trim as well. So the whole thing is weather tight. The driving rain or any rain bouncing off of the decking can't get in and underneath all this, but air movement is moving all the way around. Now that's going to solve the problem twofold. If there is any moisture coming up from down below, then this ventilation all the way around will get rid of it. That's a lovely example down there. That's going to be a really good vent when that one's finished. Now what you need to look at here is the door. This is before we put the matrix down, and if you look at the door windowsill, it's quite low. Now if you think that when the matrix goes down, that brings that up higher, and then when we put the decking down, that is going to be too low. We knew this before we started, so we've got new doors on order, and the new doors are going to go in, and the door step is going to be higher. So this is the EPDM rubber with the matrix underneath it, and you can see we've had to take out the door step at the moment, and the rubber has been run temporarily underneath it. The doors are in. These are the old doors which are in here, because this is watertight. We're waiting for the new doors to be delivered, and then we can build all this up to the new height, so that the windowsill is high enough that any driving rain doesn't get in underneath. Now this is the rest of the roof finished. We're waiting now for the cladding to go in all the way around. We've got this membrane all the way around the edges, as you can see, just keeping any weather out. Now that will be made good and battened over the top, so that again you've got a membrane which is vapor open. It allows a movement of vapor to come out, but when this is all battened out and clad over the top of it, any moisture in the building can come out through any of this all the way around. Obviously it'll be cut back at the bottom, which you'll see in a second, and all of this will be able to breathe. And this is the finished job. Decking's down now, all new cladding right the way down. You can see that this is now nice and high around the edges, so that any rain that hits the decking doesn't bounce up and get through any of the ventilation around the edges. So we've got a nice height there. Now when we go over and look at the door, you can see that the windowsill has got a really nice height to it on that door there. Again, that stops any driving rain which hits the top of the decking bouncing up and getting in over the top of that. A nice view from the side here of it all going around. Unfortunately this furniture's in the way and I can't show the outlet, but the outlet was really big by the time we had finished. And all of this is plastic decking that we've put down, some of this new composite decking, and it's all on adjustable plastic feet over the top, so it can come up in sections if it needs to for cleaning underneath it. This is a nice shot of the inside here. You can see that the windows and the door complex went in, and we've had to raise this here so that there's a step to get out, but that doesn't look uncomfortable. It's fallen in really nicely with the existing skirting board that goes around the outside, so you can step outside onto this and step back in again. It's not what we call a trip hazard. A lovely view, sun shining. It's actually really cold when we went around and did the finishing off and the tidying up, but it's a nice crisp day. But we're really pleased with this. Again, you know, it's the ventilation around the outside of this, I think, which is the major part of this job, which we're really pleased to put in to make sure that the whole thing works really, really well. So hopefully this has been informative to you. If you've got any questions, please get back to me.